Hello members, my name is Sajia Rashid and my project was about English to Luganda translation. Feel free to like and subscribe to my channel. It will motivate me to make more of these. My name is Sajia Rashid and my AI project was about English to Luganda translation. So, what's the need of Luganda translation? Luganda is the most spoken indigenous tongue in the country, Uganda. This language is spoken by the Baganda, who make up to 16.7% of the Uganda's population. In 2022, there are around 1.5 billion people worldwide who speak English either natively or a second language, including Ugandan, yes. Communication between these two different categories of people is usually hindered because of the lack of a medium to translate these languages. These different categories of people are usually tourists, refugees who come into Uganda and they face these problems of lack of effective communication between the people, and also the available AI translations are usually not accurate, mainly those of Google, because Uganda isn't they don't consider it that much in the main languages out there. So this was my basis as to why I decided to make this app. So how artificial intelligence solves this problem? Through the use of the encoder and decoder architecture in neural networks. An encoder and decoder architecture in the neural network, rather in machine learning model, composed of two networks. That is the encoder and the decoder. And what the encoder does is to get the two same architecture. The first one will be used normally, but the second one will work in reverse. So the first one gets in the data and it encodes it, and then the second one will get that data and decode it. So now to be getting the English data and it's being encoded, and then after that English data will be decoded into the Luganda, into Luganda. So now we have an image down there to show what will be happening in the network. So now a brief information about the dataset that I'll be using. The dataset that I'll be using, I got it from online from that link, and it's an English Luganda dataset that was made by fellow Macarians. And through this data, it's made up of mainly two columns. That's the Luganda column and also the English column with their respective translations. So the difference between supervised and unsupervised learning. So supervised learning, this requires labeled data, and whereas unsupervised learning doesn't require labeled data. So now they have an image here that properly explain these two scenarios very well, because supervised learning is like having a teacher. The teacher will keep on directing you to what to do and how to do it, whereas unsupervised learning it will be you to do all of the reading, all of the research. Everything is just on you. So that's the major difference between supervised learning and unsupervised learning. Here you know what you have to predict. Here you're just looking for what makes sense in the data, what things are make sense, they're related to each other, what things are related to each other, what things make sense. And that's all about unsupervised learning and supervised learning. The supervised learning technologies I'm to use in my project. I'm to use a recurrent neural network, and the recurrent neural is a type of an artificial neural network which uses sequential data or time series. It has a feature whereby the information from the prior inputs influence its current input and output, which makes it a good idea when you're using language translation, because each word, each sentence, each word in a sentence, all of the previous words reflect are necessary for the next word. If I say I want to go to school, I is needed for. They are all necessary aspects for the sentence I want to go to school. Also, there is a neural network mechanism called the attention mechanism that is about focusing on focusing on mainly the main parts of a sentence. For example, if you're reading a certain text, there are certain points or words in that text that are much more important to the rest. So That's the neural network, the attention mechanism in neural networks. And that's and through that, like the accuracy of the model becomes even much more accurate. And that's a diagram how a neural network works, a recurrent neural network. Unsupervised learning techniques to use in my project. The first is the K-means, and this is the most famous K-means, and it's all about creating different groups of unlabeled data and adding creating clusters out of them. And also and the other one is the principal access component, also known as the PCA. And this one is used mainly for dimensionality reduction. For example, if you have a usually text data is, if you represent it in numerical data, it's going to be in a 3-dimensional space. So through the use of this PCA, you're able to convert this 3-dimensional data into a 2D dimensional data, so as to make training better and even much more faster. The challenges that I'm most possibly going to face. The first challenge is that training using neural networks requires a lot of computational power, and implementing networks like the attention mechanism requires a lot of computational power, and training it on a normal PC could take like days and weeks to finish training. The other one is creating accurate models. Is also because remember, the bigger the data, the more accurate the model. So if the data set isn't that big, so that means the accuracy of my model will be a bit restricted. The other one is overfitting of the neural network, and this happens when your model is its accuracy is very high on the training data and very poor on in any other data. The irony and sarcasm used in people whereby you could say something, for example, you say I am bad when it's got two different. For example, you could say I am bad like in a good way, and also I am bad also in a bad way. Also, the ambiguity in sentence. This happens when settings have many possible interpretations. For example, you have a saying, I saw a boy on the beach with my binoculars. Could either mean I saw a boy on the beach through my binoculars, or I saw a boy on the beach with my binoculars on him. More on the challenges I'm most likely to face. One is that the use of slangs and idioms. Remember, a computer cannot be able to understand that this is a slang or an idiom, so that's a problem. Also, spelling errors. For example, saying hello with double L and single L, they are two totally different words for the computer. Solutions to these challenges. One of the solutions is to use of the free frameworks like Kaga and Google Collaborators, through which you can train a model on free GPUs, and these GPUs enable training to be very, very fast. The other is, remember, as I told you about, is that the data is limited. So through the use of data augmentation of random swarming, synonym replacement, and randomization and deletion, the data could be able to be increased so as to attain a better model. So also the use of text processing such that to get rid of spelling mistakes, whereby any text being inputted in by the user is first checked, like the spellings are made sure like they are corrected and the errors are corrected then before training. Now the difference between accuracy, recall, precision, and F1 score. Accuracy is the most intuitive performance measure, and it's simply the ratio of the correctly predicted observation to the total observations. Precision is the ratio of the correctly predicted positive observations to the total predicted positive observation. And that's the formula where TP stands for true positive and FP stands for false positives. Recall is the ratio of the correctly predicted positive observations to all the observations in the actual class. And the precision and recall metrics are summarized in the matrix, also known as the confusion matrix, as shown in the diagram below. So now a continuation on the difference between accuracy, recall, precision, and F1 score. The F1 score is the weighted average of the precision and recall. Therefore, it takes both false positives and false negatives into account, and that's the formula for the precision. That's the formula for the F1 score. AI evaluation metrics for my project. The F1 and the F1 score and accuracy, like they are more into the accurate. And remember, like how accurate your prediction is. And remember, for language translation, this accuracy varies. For example, saying let's go could be Django to Gende or just to Gende. So if you're saying accuracy and F1 score accuracy will be saying that Tugende is not the same as Django Tugende. So that's why the best alternatives are the mean absolute error and the mean squared error. The mean absolute error is the average of the difference between the original values and the predicted value. In simple terms, the model will be, it's just a measure of how far the predictions are from the actual output. For example, if the actual output was Django Tugende, it would be the model will be able to know that Django Tugende is at least closely related to Tugende. So that would be the best metric. And the final is the mean squared error, and it's similar to the absolute error. The only difference is that this one takes the square difference of the original values and their predicted values. Here's a list of all the references I used in this presentation for all the different projects. Thank you for listening. My name is Chazay Rashid and I'm working on this project because I'm pretty sure this is the type of project that will be able to ease on the communication between the different diverse communities in Uganda as a country.